All right, find the first four non-zero terms of the Maclaurin series for that. F of 0 is, well, this function is 4 minus x to the 1/2 power. So now if we plug 0 in, we get 4 to the 1/2, so we get 2. And then first derivative would be 1/2, 4 minus x to the negative 1/2, which is, if I plug 0 in, we get, well, that's going to be 1/4. Everybody good with that?
Wouldn't it be negative?
Why?
Because you take the derivative on the inside.
Yeah, chain rule, right? It's easy to miss, isn't it? Finally, I didn't make that mistake. I did that on purpose. This is the first time, though. This is the first time. I actually did that on purpose. Every other time, I just forget. I just forget. But I did remember this time. Anyway, that makes it negative. Very easy to miss that. All right, so now you multiply. We get 1/4. 4 minus x to the negative 3/2, and then times the negative 1. Times the derivative inside. So we have negative 1/4. Now if I plug 0 in there, it ends up being the square root of 4 to the 3rd. So always do the root first, because then it makes it a smaller number. So 2 to the 3rd is 8, negative 1/32. First four terms, so I got to go to the 3rd degree, is 3/8, 4 minus x to the negative 5/2, and then times negative 1. All right, negative 3/8 times, I need the square root of 4 to the 5th power. So 2 to the 5th is 32. So let's write that. Negative 3/8 times 32, that's negative 3/256. So that should be the first four non-zero terms. So P sub 3, well, of x, really. Yeah, we're going to do this with x, centered at 0, is 2 minus 1/4 x minus 1/32 x squared over 2 factorial minus 3/256 x to the 3rd over 3 factorial. Find the interval and radius of convergence for each series. So factorial says ratio test right away. I actually like it when there's a factorial in there because I know exactly what to do with this. We got 2 to the n plus 1, x plus 3 to the n plus 1, over n plus 1 factorial, times n factorial over 2 to the n, x plus 3 to the n. So we got the n plus 1s and the n's. Now let's see what we get when everything cancels out. We have an extra 2, an extra x plus 3, and then this becomes n factorial over n factorial times n plus 1. That's n plus 1 factorial in the denominator, and then we can get the factorials to cancel out. So over n plus 1. But that goes to 0 because the denominator is going to infinity. And that's always less than 1. So the interval of convergence is negative infinity to infinity, and the radius of convergence is infinite. All right, so when n is in the denominator only, we're headed to 0. This is almost geometric. Take that out, it's geometric. Put that in, not geometric, which means ratio test. X plus 3 to the n plus 1 over n plus 1, 2 to the n plus 1. So there's the a sub n plus 1. Then times n 2 to the n over x plus 3 to the n. So instead of dividing, of course, we're multiplying by the reciprocal. All right, let's see what happens when stuff starts canceling. We have an x plus 3 extra 1 up there, and then an extra 2 in the denominator. And then we have n over n plus 1. But the limit is on the ends right there. So that's 1. So we get absolute value of x plus 3 over 2. That has to be less than 1. So negative 1 less than x plus 3 over 2 less than 1. Multiply by 2. X plus 3 less than 2. So now I know that the radius of convergence when centered at negative 3 is 2. Then we minus 3 minus 5 less than x less than negative 1. So the interval of convergence is equal to negative 5 to 1. So negative 5 to 1. And you could say, you could do this. Well, I'm centering at negative 3. If I add 2 to this side, I get negative 1. If I minus 2 on this side, I get negative 5. So you're centering at negative 3 with a radius of 2. So then you just go to each side. But that's what you do when you minus 3. It's exactly what you're doing. Sometimes I do these scribbles. And then I review my notes, especially later in the year, because I only do this once. Like, how many times have we taken the derivative of x squared? A billion times? I don't need to review that. I do have to review this chapter. So sometimes I'll write these scribbles, look at it next year, and go, what is this? So sometimes I got to get rid of that. But what was I thinking there? All right, find the interval and radius of convergence for each series. Now we have 2 of the 3 types, in my opinion. We have the infinity stuff when n is in the denominator. We have just a nice interval and a nice radius when we have n's in both the top and the bottom. So we have n in the bottom, n in the top and the bottom. What do you think the next one's going to be? N in the top. How are we going to deal with that? All right, that's going to be the next one right here. So we have limit as n approaches infinity, absolute value of 4 to the n plus 1. X plus 1 to the n plus 1, and n plus 1 factorial. Over 4 to the n, x plus 1 to the n factorial. Limit as n approaches infinity. An extra 4, an extra x plus 1, and that's going to be the n factorials cancel and you get n plus 1. This is equal to 4 times x plus 1 times infinity. The limit's gone. So now the way that we can make this less than 1 is by making this 0. So the interval of convergence is negative 1. The radius of convergence is nothing. There's no radius at all. It's just one value. So n left in the top, n left in both, and then n left in the bottom. That's 3 different types of problems that you can have that have their own kind of unique little solution to it. All right, let's see what we have here. Almost geometric. Take that n out. Now you're geometric. Now it goes a little quicker because you know what your r is. But this is not geometric. N plus 1, x plus 4 to the n plus 1, 3 to the n plus 1. Multiply by the reciprocal. Limit as n approaches infinity, absolute value of n plus 1 over n. So we have n's in both the top and the bottom. Then we have, looks like an x plus 4 on the top and an extra 3 in the denominator. So this is just going to be a nice interval with a nice radius. Absolute value of x plus 4 over 3 is less than 1. Split it up. Multiply. Whoops, not 1. 3. There's your interval of convergence, and then we go -7 less than x is less than -1. So radius of convergence is 3. Interval of convergence is -7 to -1. So that was an example of just a nice one, nothing crazy, no zeros, no infinities, nothing crazy. All right, this is what do we get when the constant or the exponential part, I'll call it a constant in the bottom. Now, how do we deal with this being the constant in the top? So I have about every scenario I could think of. We have limit, n approaches infinity, absolute value of 5 to the n plus 1, x minus 1 to the n plus 1, over n plus 1. Times n over 5 to the n, x minus 1 to the n. Limit as n approaches infinity of, let's go absolute value of 5, x minus 1, yeah, and then times n over n plus 1. So now that constant, instead of being over 5, so instead of being down here in the denominator, it stayed up in the numerator. So it's not much different. Because now you have absolute value of 5, x minus 1 is less than 1. -1 less than 5 times x minus 1 less than, nope, not, what am I doing? Oh, well, I just lost focus. -1/5 less than x minus 1 less than 1/5. So there's the radius of convergence, and I'm adding 5/5. So 4/5 less than x is less than 6/5. So the radius of convergence is 1/5, and the interval of convergence is 4/5 to 6/5. Well, what's between 4/5 and 6/5? What's halfway in between? 1, right? Because we're centered at 1, 5/5. So 5/5 right down the middle. We're centering at 1. Anyway, that's about every scenario that I could think of. Make sure you look at those before the test tomorrow, and you should be fine. Find the power series representation in sigma notation for f of x equals that, centered about x equals 2. Also specify the radius of convergence for the series. Well, you only know one function. I only know one function for this chapter. That's it, a sub 1 over 1 minus r. That's all there is to it. But we want to center this at x equals 2. So we're going to write this f of x equals 3 over 1 plus x minus 2 plus 2. There's the trick. There's the trick right there. To get this to be centered at 2, you need x minus 2. But I can't just minus 2 from a denominator. You can't have the number 3/4. Go, well, I'll just minus 2 and make it 3/2. That's not allowed. It's not the same thing. But if I did this, and I think you get the point, all of a sudden it's back to 3/4. So we add 0 to the denominator. All right, well, we get 3 over 3 plus x minus 2. So now it's starting to look again like the a sub 1 over 1 minus r. But the rule is this needs to be a 1, that needs to be a minus. So let's multiply everything by 1/3. There, everything got multiplied times 1/3. Now we have the first rule where that's a 1. Now we just need to make that a minus by going minus negative. And this is a geometric series. So a sub 1 is equal to 1. R is, I don't need parentheses, I'll leave it. There's your R. So it says, I'll scroll back up real quick, find the power series in sigma notation, radius of convergence. All right, so now this is going to be 1 minus 1/3 times x minus 2 plus 1/9 times x minus 2 squared minus 1 over 27 times x minus 2 to the 3rd plus keep on going. So there's the power series. There's the geometric series. The sigma notation, n equals 0 to infinity of, it's alternating, -1 to the n. And then x minus 2 to the n. Now, I kind of want to use this white space up here. We'll go absolute value of negative. Oh, I forgot the 3, didn't I? Forgot the 3. Look at it. Totally skipped it. Over 3 to the n. There you go. I missed that. Oh, I don't need the negative when doing this either, because the negative isn't going to change what the interval is. All right, so let's do this. 1/3 x minus 2 has to be less than 1. Negative 1 less than 1/3 x minus 2 less than 1. So negative 3 less than x minus 2 less than 3. So the radius of convergence is 3. If you're looking at, what should you look at for the test? That's it right there. That's the key to this problem. That gets it all started. Centering it too. Use the power series representation of sine of x to produce a power series representation in sigma notation for f of x equals all that. Give the first 4 non-zero terms and the general term. So once we get the general term, writing the sigma notation is just saying where we're starting. Let's start with sine of x, kind of the parent function. Sine is odd, so x minus x to the 3rd over 3 factorial, x to the 5th over 5 factorial, x to the 7th over 7 factorial. Let's replace x with x squared. X squared minus x to the 6th plus x to the 10th minus x to the 14th. Over 3 factorial, over 5 factorial, over 7 factorial. Replace first, then do the multiplication. So 2x sine of x squared is 2x to the 3rd, 2x to the 7th, 2x to the 11th, 2x to the 15th. Now we're supposed to write the general term. I think let's start at 1. I could probably start at 2. I could probably start lots of things. 0, but usually 0 and 1 gets the job done. Now I'll adjust to starting at 1. Well, it's alternating. Negative 1 to the n plus 1. I got to do plus 1 because it's starting as a positive, not a negative. Everybody has a 2. And the powers are increasing by 4. 3, 7, 11, 15. That means the slope is 4. But now if I plug 1 into this, I get 4, and I want it to be 3. So we better minus 1. And then over, this is really over. To fit the pattern, I should probably say that that's 1 factorial. There, it fits the pattern by adding 2 every time. So this is 2n. But if I plug 1 into 2, I get 2, and I want it to be 1. So we're going to do minus 1 factorial. Now we could start at 0, but then I'd have to adjust it to fit to 0. So when I write the keys, I have to have a couple answers. That's my problem, not yours. You just got to give me one answer. Any questions? Determine if the series converges or diverges. Make sure all conditions are met. This is geometric. R is equal to 1/3. Absolute value of 1/3 is less than 1. So converges by geometric series. The mistake I could see on this one is saying R is 2/3. But you're not, the 2 doesn't have the n with it. So the first term would be 2/3, and then the next term would be 2/9. Next term would be 2 over 27, and so on. So the R is 1/3, not 2/3 for this. If that said 2 to the n, now the R is 2/3. So be careful with something like that, I suppose. Alternating series over here. Limit as n approaches infinity of 1 over 3n minus 2 is equal to 0. So that fits the nth term test. That's a pass. And then 1 over 3n plus 1 minus 2. 3n plus 3 minus 2. So 3n plus 1 is less than 1 over 3n minus 2. Well, yeah, absolutely, every single time. Because if you take 3n and add 1, that's going to be a bigger denominator than minusing 2. So that'll be a smaller value every single time. So I feel good about writing converges by alternating series test. I don't know, that one jumps out at me so glaringly. Anyone know what that one's going to be? Does that, what is it? Yeah, that's nth term test because it's going to be 2/4. That's not 0. So limit as n approaches infinity of 2n to the third plus 5 over 4n to the third minus 1. That's equal to 1/2, which is not 0. So converges, no, not converges, excuse me, diverges, shame, by nth term test. So hopefully that one's, I don't know, eventually it's going to be obvious to you. This is alternating, and we got to do nth term test of n over n squared plus 5 is equal to 0. So it passes the nth term test, which is good. But then we have to be able to say n plus 1 over n plus 1 squared plus 5 is less than n over n squared plus 5. And if the numerator and denominator are changing, then this function will decrease eventually. So we say for all n greater than or equal to something. So f of x, we're going to let f of x equal x over x squared plus 5. The derivative is bottom times the derivative of the top minus the top times the derivative of the bottom over bottom squared. So this is equal to x squared minus 2x squared. So 5 minus x squared over x squared plus 5 squared. Now we want the top to be negative. So I want 5 minus x squared to be less than 0. So negative x squared is less than negative 5. So we minus 5 over there. Divide by negative 1. X squared has to be greater than 5. So x has to be greater than square root of 5. So n greater than or equal to 3. So we can show that it's an eventually decreasing function. So we finally say converges by alternating series test.